Good evening. This is your Captain Shreyas. Welcome to the Vedantu JEE English channel, the number one English channel for JEE students. And now we are already on to the next class of Ray Optics unit. These are detailed classes, lecture by lecture, right from the scratch to the JEE level. So welcome aboard all the kids out there. We are focusing today on refraction at curved surface. Last lecture we saw Snell's law, plane surface, apparent depth, glass slab, lateral shift, all those things. Today, refraction at curved surface, and when you combine two surfaces, you get a lens. So lens formula and all of it, magnification, power, everything in today's class with me, your your Captain Shreyas on the channel, my dear warriors. Welcome Varshi, Vijay, Amitav, Abhinav. I hope you guys are doing great, fabulous, fantastic. And it's time to move on, guys. And kudos, a pat on the back for attending all the classes live or even recorded. A lot of kids attend the classes recorded because you have some coaching or school or whatever reason. So kudos to you to smash that like button and subscribe to the channel right away right now. Good evening, Rama, Sandhya. Yes, neat aspirants are also here. Oh my God, wow, very good. I don't mind, guys. As many students, the better it is. You will be motivated. Plus, you're learning a lot. And at the end of the day, it is knowledge. So knowledge is there everywhere. Absorb it. Okay. So let's move. And just a gentle reminder, many kids are like last minute people. They complete project on last minute. Homework also will do last minute. Studies also will do last minute. So if you have not yet registered for MVSAT, register for that also last minute. Because this Saturday, Sunday, just tomorrow and day after, last 2 dates, your last chance to get prizes, hampers, scholarships, study material, resources, counseling, meeting teachers, all of that last 2 days. You better hurry up and register for the exam. The link for the registration is there down in the description box of this particular video. Okay. So go down over here in the description box and you will see MVSAT scholarship test. It's the biggest scholarship test which we have. Okay. Pan India. So visit your nearest center for, taking part in it. But you have to register first. Okay. Or else you cannot just go there and say, oh, I want to write the test. Okay. So I'm so glad to see you too, Rama and everyone. So let's begin with the concept of refraction through spherical. Ayo. This is not. 1 second, guys. My PDF which got downloaded was a wrong PDF. So I'm re-downloading it again and opening it again. Just hold on. Yeah. Just hold on a sec. Yes, I've been now waiting for it. Sir, if I start from now also, can I crack JEE 2026? Watch this video. I made this video on the channel, how to crack JEE from October. Okay, there is a beautiful video. Just check it out. October plan. I have given that. Where is it? Where is it? See, October to 99 percentile. Okay, just 8 days back, I have made that video. So check that video out. Okay, in the live section, it will be there. All right. So let me open my session. Okay, I think some wrong PDF got downloaded. No worries. Let's start. Okay. Refraction through curved surface. These are some live examples of refraction through a curved surface. Plane surface means the surface has no bends. Look at this. This is a paperweight made of glass. There is some fancy material inside. So the light rays, when they come out of that glass sphere, they are going to bend. But remember, every part where they bend, the surface is inclined at a different angle. So where I'm going to see the image will depend on the curvature, refractive index, where that fancy material is, all of that. So this is a beautiful example of it. This is a Jurassic mosquito. Jurassic mosquito means this mosquito lived when dinosaurs were there. And a fossil of it was found. and this is covered in some amber glass. Okay, it just happened to be like that, and you are seeing it from outside. Maybe the mosquito is not actually that big, maybe it is much bigger. It depends, because what is the material filled inside, what's the refractive index, what's the curvature, so that decides how the rays will be refracted and how big or small the image will be formed. Getting my point? This might not be the actual size of the mosquito, it is what you are seeing it to be. It's a virtual image. All right. Same thing over here. This is the meniscus of a curved meniscus of a liquid. Whenever you pour liquid in a tube, you will see the surface is curved. And let's say you are seeing it from the top, then whatever is inside will look slightly differently as compared to when it was flat, or when it is bulged out, or when it is bulged inside. So all these are examples where light bends through the surface which is curved. So hence we are calling it a curved surface refraction. Okay, refraction through a spherical surface or curved surface. Okay, I hope this is absolutely clear. Sandhya, it's very difficult, man, to take care of so many things, and plus you can watch my lectures here only. Okay, and if you want, you can watch physics and chemistry, maths, sorry, biology classes in Vedantu NEET English also. But if you prefer to watch my class, please feel free to come here. And when the time comes, I will come there also. Don't worry. Okay. So let's begin with the formulas of it. See, if this is the curved surface, if this is the curved surface, and let's say, oops, okay, you cut that surface into two equal parts, that becomes your principal axis. It's a part of an imaginary sphere. So this side you can think as if is made of a different material altogether. So this orange shaded part is some glass, some liquid, some transparent body, okay, which is having some kind of maybe refractive index. Let's say I call it as mu2. This side has a refractive index of mu1. Okay, this side has a refractive index of mu1. This is the center of that imaginary sphere, so center of curvature. This is the center of that curved surface, so it will be the pole. Okay, and then I can clearly say that this particular distance which you see from P to C, this is nothing but R, which is radius of curvature. Radius of curvature. So this curved surface is separating two different medium, mu1 and mu2, with a radius of curvature R, C being the center, P being the pole, which is the midpoint, and this gray dotted line is the principal axis. The gray dotted line is nothing but your principal axis, which divides the two thing into two parts, principal axis. Now, if you consider any ray which will enter this particular surface, it will follow Snell's law no matter where it is. So, say for example, we have some kind of an object, maybe over here. Let's say this is our object. This is our object. Okay. The rays coming out from this particular object will go something like this. Every single place like this, then maybe over here also, and maybe over here also, like that. Every single place they will go, and they will get refracted at those places. When they get refracted, it has to follow Snell's law. So if you think of the normal drawn, it will be like this, maybe even like this over here. Remember, the normal drawn has to pass through the center of curvature at the end of the day. Okay, because that's also the radius of that imaginary sphere. Now, if this is rare, this is dense, it will bend towards the normal. If this is dense and this is rare, it will bend away from the normal. So you can take it anything. So let's say, for example, it is a denser medium. So from rare to dense, it will obviously bend towards the normal. Maybe the rays meet here. Okay, maybe this particular, actually, it might meet over here. Okay, this might meet, this might maybe meet over here like this, but this when it bends, it will probably go on this side. So most likely, I feel this could be kind of an inverted image or something. I don't know. Chumma, I'm just drawing it randomly like this. Okay. Now you can see the rays basically after refraction, they are meeting over here. That means this is the location where your final image will be formed. Okay. This is the location where your final image is formed probably. Okay. You can see it is a real image because the rays are meeting. It's also inverted and maybe also diminished because it is looking of small size. Now, what is the nature of image, etc.? I'll tell you the formula. I mean, from the values you can make out whether it is inverted, etc. Don't worry about it. Yeah. So, sir, is it irrespective of the surface? I mean, Rama, I mean, where it will meet depends on how the surface is curved, how much it is curved, which side it is curved, what are the refractive indices, and where the object is placed. If I change the object position, curvature, material, then it will maybe meet, maybe it will produce virtual, maybe it will produce erect, maybe magnified, any kind of image can be formed. I'm just showing you how the refraction occurs. So, Snell's law is obeyed. Snell's law is obviously obeyed at every point, at every point, okay, of it, and you will definitely get some kind of an image, and where that image is formed and what's the size, everything I'll tell you. So first of all, let me start telling few terms over here. If this is my object, then this is my object distance. If this is my image, if this is my image, then whatever distance you measure from the pole till the image, that is your image distance, of course. And radius of curvature, I have already spoken about it. This particular thing will be your radius of curvature. Okay, this will be your radius of curvature. Then the formula goes something like this. Observe it carefully. Mu2, which is the refractive index where the refracted rays are present, that is the rays after entering the medium, wherever they are present, the refractive index of that medium. So that's why mu2 by V, which is image distance, minus mu1, which is refractive index where the incident rays are present. As you can see, these are the incident rays. Mu1 is the refractive index of that medium, divided by object distance is equal to over here, you will have radius of curvature as it is over here. This will still be minus, okay, and here again you will have the same thing, mu2 first and then mu1 next, mu2 minus mu1. This formula helps me find where my image is. Radius will be known, refractive indices will be known, u will be known, you will find v, or if v is known, you can find u, one and the same thing. Okay, so this is the formula. Mu2 by v minus mu1 by u is mu2 minus mu1 by r, following sign convention as before. So you have to follow the sign convention. So I'll mention what each of these terms are once again. Mu2 is the refractive index of the medium where refracted rays are present, where refracted rays are present. The next one, mu1, is the refractive index of the medium where incident rays are present. Incident rays are present. Keep this in mind. While using these equations, you have to follow the same sign convention which was discussed previously in mirrors. Same sign convention you have to follow. You cannot skip that. Lastly, the magnification part. Okay, the magnification part, that also I will tell you. So this was where the image is located, but what is the size of the image upon size of the object? That is obviously called magnification. So the magnification, the magnification, the magnification M, which is height of the image upon height of the object, height of the image upon height of the object, that is simply given by, now usually for a mirror it used to be negative V by U. Here in refraction negative will not come. Yes, negative will not come. Instead you will have V by U, but before doing V by U, remember with V and U, these refractive indices will also come, which is mu1. So it will be U by mu1 in the denominator, and over here this mu2 will also come. Okay, so this will be V by mu2. So this comes after derivation. Let's not worry about that, but I'm teaching you a way to remember these formulas. So for mirrors it was minus V by U. For refractive surfaces, lenses, any curved surface, it is positive V by U. Secondly, with V, divide that medium's refractive index. With U, divide that incident rays refractive index, which is mu1. Okay, so that gives me size of the image by object ratio, which is called magnification, which is the magnification. Is this absolutely clear till this point? So these are the formulas, and this is for your reference how it works, and these are some live examples of curved surface refraction. So I think it's a good time that we look at some questions. Let the question go. Something is wrong, guys. This question from somewhere else has come over here. Some mismatch has happened. These slides are, one second, let me find that slide if I can. Okay, anyways, this is not the question. Right, I think this is the question. Okay, anyways, look at this question. This was asked in JEE 2025. You can see there is a curved surface. This side is having refractive index of 1. This side is having a refractive index of 1.5. The object is at a distance of 0.2 meters from the pole. You have to locate where the image is formed. Okay, the distance of the image from of an object O is which side is it and what distance is it. Okay, so let's take up this particular example, my dear students. Okay, let's take up this particular example. I don't need all of this. Okay, read the question, think which side will be positive, which side will be negative, which all distances do you really know. Okay, let's write down the formula first over here. It is nothing but mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. As one can see, the object will produce the rays like this. The pole will be the center, the origin. So this side will be positive, obviously, and this side will be negative. So what is mu2? Mu2 is basically that medium or the refractive index where the refracted rays will be present. So as you can see, just a bit, I don't know. Okay, I'll have to redo it again. So sorry. My hand touched the board. So mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. So mu2 is the refractive index of that medium where refracted rays are present. So it is this medium. So mu2 is basically 1.5. Mu1 is refractive index where incident rays, that is where the object is placed. So that is having a refractive index of 1 is equal to 1.5 minus 1. So I have taken care of the numerator first. That's how usually you should proceed in the question. then it becomes easier. Now think about each distance separately. Like first of all, radius. The surface curvature is here. So when you think of the radius, it is on the positive side, okay, of the convention. So it will be plus r. R is nothing but 0.4. Image distance is what I don't know. So I'll put it as an unknown. Only thing remaining is u, which is object distance, which is on the negative side, and it is basically 0.2. Now you have to solve this question. 1.5 means it is 3 by 2. Okay, minus and minus will become plus. 0.2 means 1 by 5. So 5 will go on the top is equal to 1.5 minus 1 means 0.5. And this is basically 0.4. You just have to solve this now. So therefore, this will become 3 by 2v plus your 5 will be equal to 0.5 by 0.4 is 5 by 4. So I will just leave it as 5 by 4. So therefore 3 divided by 2v will be 5 by 4 minus 5. So taking the 5 common, 1 by 4 minus 1 is nothing but minus 3 by 4. So here we'll have 3 by 2v. Obviously 3 will cancel, 2 will also cancel, and 1 by v will be negative 5. 3 has gone, 2 has gone. So 1, 2 is remaining. Therefore, v will be negative 2 by 5. Now, negative 2 by 5 means minus 0.4 whatever meters. Yes, they have used meters, so we'll use meters. So minus 0.4 meters. Now minus 0.4 meters means it is on the which side, guys? It is on the left side of basically the origin. All right. So as you can see, 0.4 meters to the left of the spherical surface. That is the absolutely right answer. Understood how to solve this? Yeah. Yes, Azad, whatever mistake you have made, please put it up in the comments after the session is over. I'll look into it. Yeah. Okay, Jayant, noted. So in this particular question, I will explain this particular question again because this is a very important substitution based question. In this question, what was given? Object is here, surface is here, center is here, radius is given, mediums are given. Where is the image formed? So what we did, we showed the rays coming out from the object. Because it is going this side is positive, this side is negative. Okay, this pole is the origin. Now we wrote down the formula. This formula I just explained it to you over here. Where is it? Just over here. Mu2 by v minus mu1 by u is mu2 minus mu1 divided by r. So now what we did next? We substituted the values. Refracted rays will enter this medium. So this medium will be mu2. Incident rays are here. That medium has refractive index of 1. Same things I will put it over here. 1.5 minus 1. Now v I do not know. Object distance is on the left side, so negative, so minus 0.2. Radius, for radius, check where the center is. The center's coordinates are positive, so hence radius will be plus 0.4. Now after this, it's pure calculation, which I feel everybody can do. Okay, Rama, everyone understood this question, how to solve this? Shall we do the next question coming up on your screen? And here it is. This was also asked in the year 2025, that means this year only. So let's see what is asked. There are two concave refracting surfaces of equal radii and refractive index facing each other in air as shown in the diagram. A point object O is placed midway between P and B. Between P and B. Okay, fair enough. So the question is the separation between the images of O formed by each refracting surface. Interesting question. So I'll tell you what we can do. First of all, I don't need this. The separation between the images formed. So there are two times I have to apply the formula because two images will be formed. Once I know where the images are formed, I can easily figure out the distance between them. Okay. So here is what we will do. First, we'll take the left side, then we'll take the right hand side. Okay. Let's not burden ourselves. Let's take one side at a time. So let's not worry about this for now. Let's not worry about this for now. We'll worry about it in the next go. So in this particular scenario, as one can see, this is the object. So the rays will be coming obviously like this. So this is the pole origin. So right side will be positive and left side will be negative. Okay. So this is where the incident rays are. So mu1, the first medium is this one. This is air, so it will be 1. This is glass. I think they would have given refractive index of the glass is 1.5. So this is the second medium. So mu2 is basically 1.5. That's about it. So let's start solving. Mu2 by V minus mu1 divided by U is mu2 minus mu1 divided by R. So what is mu2? It is 1.5. Where is the image? I don't know. Mu1 is 1. Mu is negatively placed. It is on the negative side. So minus R by 2. Same numbers here, 1.5 minus 1. Radius is also on the negative side, and the radius of curvature of both the surfaces is given to be R. It is basically given to be R. Keep that in mind. So it will be minus R because the radius's center will be over here. The center of curvature of that particular surface will be on the negative side. So minus R. Now we just need to solve this. 1.5 means 3 by 2. So put 3 by 2 V. Minus minus means plus. That number 2 will go on the top. R will stay below. This will be 1.5 minus 1 means 0.5, but with a negative sign. So 0.5 means half. So minus 1 by 2R. Okay. So that is what this is. I think it's best to shift it over there. So 3 divided by 2V will be minus 1 by R is common. From here 1 by 2 is there, and from here we will have the number 2. So this will be minus 1 by R, and 2 plus half, basically 2.5. This is 0.5, which is nothing but 5 by 2. Okay, so that is what this is. This is 3 by 2V. Perfect. 2 cancels. Therefore 3 by V is minus 5 by R. Therefore V will be minus R goes on the top with 3 and 5 comes below. So minus 3R by 5. So minus 3R by 5 is from point B. Keep that in mind. Minus 3R by 5 is from the point B. Okay, keep that in mind. Right. Let's do the other part over here now, which is this side. Let's not worry about this now. Okay. In this scenario, what happens is the rays are going like this. This is the pole. So wherever they go, that side becomes positive. This will be negative. This is the first medium. So mu1 will be air, which is 1. Glass means it will be 1.5. And object distance, guys, observe carefully. This was R by 2. Okay, this was R by 2. So object is technically R plus R by 2 distance away. Object is technically R plus R by 2 distance away. R by 2 distance away, which is nothing but 3R by 2. So object is 3R by 2 distance from the pole. Let's again apply our formula. Mu2 by V minus mu1 by U is mu2 minus mu1 divided by R. What is mu2? Already known, 1.5. Image distance unknown. Mu1 is nothing but 1. Object distance is 3R by 2, but on the negative side, as you can see, negatively placed. So minus 3R by 2 is equal to same numbers here, 1.5 minus 1 over here. R, radius is again on the negative side because you can see the center of curvature will be here. Okay, the center of curvature will be over here. So it is definitely on the negative side. So minus R. So now again solve it. 1.5 means 3 by 2. Minus minus is plus. 2 goes on the top. This is becoming 3R. 1.5 minus 1, 0.5. But with a negative sign. So minus 1 by 2R. Take this over there. So 3 by 2V. R is common with a negative sign. Okay, 1 by 2 is there. And from here, you have 2 by 3. Okay, so this is becoming minus 1 by R. LCM is 6. 3 plus 4 is 7. So this is 3 by 2V. Okay, so yes, 2 and 6 will cancel. Therefore, 3 by V will be minus 7 by 3R, I believe. Yeah. So from this, V will be minus 9R because 3 threes are 9 divided by 7. So we got the image distance also. Okay. JPU already mentioned the list of all the important topics over here. If you have not yet seen that particular video, please check it over here, October to 99 percentile, or go to the video section and just check this video. I've explained how to open the link, the PDF, everything. Okay. Don't spam. Once we get this, now you have to substitute, guys. Now you have to substitute in this diagram. I'll tell you how. In this case, V was minus 9R by 7. So from point A, the image number 2 is at a distance of how much? 9R by 7. This is 9R by 7. Whereas for image number 1, the distance is 3R by 5 from this surface. The points taken are only different, okay? The poles are different. So it is 3R by 5 from point B. 3, this distance is nothing but 3R by 5. Now they are asking you what is the distance between I1 and I2. How much is basically this? Well, we already know from point A to point B, this is R, this is R. So this total distance, if you measure, that was already 2R. So from 2R, 9R by 7 goes, 3R by 5 goes, whatever is remaining is basically X. So technically, X is nothing but take your 2R distance, from that take away 9R by 7, and from that also take out minus 3R by 5. That's it. So that is what will get you towards the value of X, which comes out as in decimal places 0.114R. Understood how to solve it? Everyone, isn't it a good question? This question has come in your JEE 2025 examination, my dear students. So it will take a lot of time. Ideally, I would solve this question towards the end, not in the beginning, because it might lose or break your confidence. So better to keep it somewhere at the mid or towards the end, because it is lengthy and obviously above average level, not for everyone. Okay, got it? Because sign convention has flipped, distances are measured from different places. Again, you have to use some basic geometry. If you love the question, smash the like button right away right now, guys. Time to move now to the next concept. Okay. Now, here we are talking about lenses. See, guys, in case of a single surface, those questions are very limited. Mainly, you get multiple surfaces, which is lens. If you take two curved surfaces and club them together, it is nothing but a lens. Like the lens which is put on the eye cap, on the eyelid, sorry, on the eyeball, my bad, to replace your goggles or specs, or the lens of a camera, or the lens of a binocular, or in general any lens which is used maybe in a microscope, telescope, or some optical device. So they have a variety of functions. These are some of the applications. Usually these cameras, binoculars, and even these things, they are complex in nature because they have multiple lenses sometimes within themselves, and they're not just one singular entity. So a lens is nothing but two refracting surfaces combined together. That's it. Yeah. Okay. Now, as you can see that we can have multiple types of lenses, like the standard ones. First, let me talk about it. This one. This is basically called as a convex lens. Convex lens. Then you have a plane surface, and like this is plano convex lens. Then you have something like this, This is concave lens. Then you're going to have a plane surface like this, and this goes like that. A plane surface with a concave surface in between. So plano concave lens. You can also have a convex surface like this and maybe a different curvature like that. So one side is convex, one side is concave. So this is convex o concave or concavo convex, whatever you want to call. So these are the different kinds of lenses that you can have. Simple. Now, once we understand it, let's understand the different nomenclature of a lens. Starting off with, let's say, if you take a convex lens versus concave lens. If you cut the lens into two equal parts, that line is called as the principal axis. That particular line is called as the principal axis. The point on that principal axis, which is exactly in the middle of the lens, that is your pole or optical center. Okay, that is your pole, you can say. Then, if the rays are coming from one side, it's a parallel beam of light. If it passes through any kind of convex lens, you will see the rays will converge at a point, versus for a concave, it will diverge, appear to diverge from a point. It will appear to diverge from a point. That particular point where it actually meets or appears to diverge, that is called as the focal point. That is your primary focus, you can say. Yeah, that is called as primary focus or just the focus. There is another focus on the other side, but the significance is if the light comes from the other side, then it will be the focal point of that particular light. So if this is F at the same distance on this side, this is your secondary focus. This is your secondary focus. Same thing here, F, you will have F2 over here. Primary focus, secondary focus. Very simple nomenclature that it has. Yeah. Now you can also mark the radius of the curvature of those lenses. Observe this carefully now. Say for example, this is the first surface because it hits the light first, this surface. Okay. So if you extend that surface, it becomes a sphere. Maybe the center of that imaginary sphere, which the surface is a part of, is somewhere over here. So this is center number 1. So this radius will be radius number 1. Got it? Similarly, this particular surface might be a part of another sphere whose center is somewhere here. So maybe I can show this is center of curvature 2. And this then will become radius of curvature 2. How to choose 1 and 2? It depends on the direction of light. If light is coming from this side, wherever the light will hit first, that surface's radius will be R1. Wherever the light enters next, that is the second part or the second surface, that's why R2. Understood how R1 and R2 is defined? Everybody? Great. Next, in this particular lens, as you can see, the surface on this side is getting hit by the light first. So the center will lie somewhere here with some kind of radius. So maybe, just maybe, this is the first center and maybe this is the radius 1. This surface might have center here. This could be the radius. So maybe this is C2 and I can just say this is nothing but radius of curvature labeled 2. So these are the things regarding the construction of a lens, the points on the lens, the axis of the lens, all the important parameters of the lens that you should know. Everyone? Okay. Okay. I hope this is very, very clear. Very, very clear. Amazing. Now that this much point is clear, okay, there are different kinds of lenses. So right now I've shown you these are the types that we'll be studying. Okay, convex, plano-convex, concavo-convex, and all of that. And what are the points of a lens? How do I locate where the image will be formed because of these lenses? There are again two ways. Either you draw the ray diagram, which is very crude, very basic, but useful at times. But the second one is via the lens formulas. So, which is the formula method. First, I will show you the ray tracing, which is very straightforward. Just like you had ray tracing for mirrors, same thing is also there over here. So, say for example, you take convex lens like this over here. There are only 3 rules which you should know. If you know these 3 rules, you are sorted. Okay. This is the principal axis, and this is the principal axis. Same thing over here. Principal axis, principal axis, principal axis. Okay. So what are the rules for tracing images? Okay. First of all, obviously you should at least have 2 rays to locate an image. With 1 ray you can't. 3 rays are okay, more than enough. But 2 is bare minimum. With 2 rays enough, you can easily locate an image. So what are those rules? The first rule is that if a ray is parallel to the principal axis, then after refraction, it will pass through the focal point or appear to pass through the focal point in case of a concave lens. So this is the first rule. Any ray which is parallel will pass through the focus or appear to pass from the focus for convex and concave. The next one is exactly the opposite of it. If a ray is somehow directed towards the secondary focus, if a ray is somehow directed towards the secondary focus, meaning something like this. 1 second, guys. It is okay. This point over here is my secondary focus, and my light ray is somehow directed towards it, towards the secondary focus. Keep this in mind. Then after refraction, it will become parallel. It kind of makes sense if you use reversibility principle of light. If a light ray is parallel, then after refraction, it will diverge from the focus. Then the secondary will become primary if the light ray changes the direction. So this is secondary focus exactly on the opposite side. Same thing over here also. The secondary focus will be over here. So if a light ray passes through the secondary focus, then after refraction, it will become parallel. So this is again your F2. Okay, very simple and sweet. And the last one is if a light enters at the geometrical pole, then it goes undeviated. Then there is no deviation at all. So it just passes as it is. That's all. In case of mirrors, if you remember, when there was a mirror, the light used to go and reflect back symmetrically on this side. But it will not reflect here, it will go on that side as it is. That's all the difference between lens and mirrors are. So with these 3 rules, it's more than enough. You can locate any image due to an object in front of a lens. Okay? I hope this is absolutely clear. Great. My brightness, is it less? Is that so? And you just check the brightness of your computer screen also. My computer screen, I think till now nobody has told any problem. But if you are insisting, I'll just change it a little bit. Hopefully it changes for you. Okay. Now, if I give you some example, let's say we take the example of this convex lens. Chumba have taken some random example, okay, and let me start marking the focus and everything. So maybe somewhere over here we have focus, exactly same distance. We should have the secondary focus. Okay, let's say our object is placed maybe over here. Randomly I have shown it. This is my object. So the rays coming out from the object, I can show many of them. Like one of the rays will go like this, parallel, and after that refraction, it will go through the focus. So let it continue through the focus infinitely long. Next, if a ray passes through the optical center, it should go undeviated. So it will go undeviated like this as it is. If you want to show another ray which passes through the focus, I know it was not going to meet anywhere over here, but if I could, then I would have shown it probably like this, and after that it would have become parallel and again gone over here, but it is not possible because the lens is thin, not very wide. So okay, you can ignore that. So as you can see, this is where the image is going to be formed. So this is the location then of the final image. This is then the location of that final image which is formed. So I can just mark this as I. And as you can see, this image is obviously slightly bigger than the object. It is also inverted and real in nature. Real because actually the rays are meeting. Inverted because it is upside down. Bigger because it is seen that it is bigger. I mean, it's obvious. So this is how you can locate the image, guys. Very easy peasy lemon squeeze. I'll show you one more example, but this time of a concave lens. Okay, this time of a concave lens. Let's take concave lens, guys. Okay, and this is our principal axis. The focus will be somewhere here, and exactly same distance. This will be the secondary focus. Let's say my object happens to be somewhere over here, and see what exactly happens to that particular object. Okay, the rays will go everywhere. You can keep the object anywhere, guys. You can keep it here also, you can keep it here also, you can keep it here, anywhere you want. You can keep it accordingly, the image will change. You can keep it anywhere. So let's say I show any one ray like this. Okay, it is going parallel. So after refraction, what should happen? It should pass through the focus. It should pass through the focus, but it can't really pass. So it will appear to pass through the focus. So I'll just draw a dotted line to show that, see, it feels like it is passing through the focus when extended in nature. Any other ray that I can draw? Maybe a ray which passes through the optical center. Yes, I can show it like that. It will go undeviated. Okay. Now, are the rays actually meeting? No. If I extend this ray backwards and this ray backwards, then they appear to meet over here. So this location which you see, this is exactly where that image is. This was object, and obviously this is the image location. This image is erect because you can see it is still up. It is smaller in size, that means diminished, and you had to extend the rays, that means it is virtual. So if somebody observes this from this side, this object through this lens, he will see a small image of that object in front, which is erect in nature. In this scenario, this image will not be seen like through the naked eye, but you'll have to take a sheet or some screen to see that image. Got it, everyone? Absolutely clear? All right, all right. Sir, you and another Vedantu teacher made a session on ray optics. It was wonderful. Oh, yes. I think last year, is it? Madan, sir, you're talking about maybe? Sir, DC Pandey Aryan series enough for mains and advanced. Mohan, it is good enough, but not the best enough. If I do PYQs, how many marks can I score in JEE Mains? If you do only PYQs, it depends on how many PYQs you are doing. But if you do good enough PYQs, A 95 percentile to 96 is also possible. I mean, it's not difficult. Okay. I hope that is clear. All right. But see, guys, this is a very crude formula. I mean, sorry, crude way. Ray tracing. This is something which you should not generally use. This is very basic level. We'll obviously go with the formula method. So what is the formula method? See, we have the lens maker formula. Just some time back, I told you the different points and properties and terminologies of a lens. So same thing, we'll use it over here, lens maker formula. So if you have any kind of lens, doesn't matter. This is one surface, maybe this is another surface, doesn't matter. The surfaces are also not equal, as you can see, and maybe this is the curvature of this guy, maybe this is the curvature of this guy. So as you can see, this is center 1, this is center 2, this is radius 1, this is radius 2. The lens medium, the lens is made of some material. I will just call it as mu L, and it is placed in some medium surrounding it, maybe mu M. What is mu L and mu M? Very, very important. It is the refractive index of the lens material, whether it is of glass, silver, whatever, I don't know. Okay, so mu M is nothing but refractive index of the medium outside the lens. If it is dipped in water, it's in air, it's in some liquid medium, or refractive index of medium which is outside the lens. Okay. Then the focal point, that is, if the rays were parallel, where will they meet? If the rays were parallel, where will they meet or appear to meet? That point is that focus. So if you measure this distance, that is nothing but your focal length. That is nothing but your focal length. This focal length has a formula given by 1 by f is equal to, very, very important, observe, refractive index of the lens upon refractive index of the outside medium minus 1 into 1 by first surface into minus 1 by second surface. That's it. This gives me the formula for the focal length of the lens. That's why it is called lenses maker formula. To make a lens of a particular focal length, this formula you should use to figure out what radius, what material should be used. Yeah. Obviously not, Likita. He's not there in Vedantu now. Yeah. Okay. Great. I hope this is absolutely clear. This is how you can, figure out what is the focal length of the lens if refractive indices, radius, everything is known. Don't worry. I'll help you out with the questions. We are going to solve the questions right now. Before going to the questions, okay, 1 second. Yeah. Optical power. The power of a lens, remember, power of a lens is nothing but, the degree of convergence or divergence, the degree of convergence or divergence. Now, whenever it is diverging, the power is negative, and whenever it is converging, it is basically positive. Example for converging lens is convex lens in air, whereas example of diverging lens or diverging power is a concave lens in air. So if we take a concave lens, the rays will diverge, so negative power. Convex lens will converge. Okay. So the power formula is very simple. It is just 1 by F. F, if it is in meters, then the power is in diopters. Never keep it in centimeters. For SI units, keep that in mind. In mirrors, it was negative 1 by F. That's what I want you to recollect. The formulas are very similar looking. Same, but different. Signs are different. There is no minus sign here for a lens. For a mirror, there was minus 1 by F. Yes. Yes, it is sign sensitive. Everything is sign sensitive. F is negative, P is negative. Like if you take a convex lens, then the focal length will be positive, power will be positive. Diverging concave lens, focal length and power both will be negative in nature. Not just here, but even here. R1, like over here, it will be positive, R2 will be negative, all of that. Sign convention is valid. Okay, so let us do some examples on this first before going ahead. Imagine there is a lens like this. I just want you to tell me the formula that you will use. Let's say this is 3 meters. Let's say this is 5 meters. Let's say the refractive index is 2. Okay. If I have to find the focal length, what formula will I use and what will I substitute? 1 by f, of course, is this minus 1 into 1 by r1 minus 1 by r2. So what is mu L? What is mu M? What is r1? What is r2? First, refractive index of the lens is 2. Outside medium is air, so it is 1. So minus 1. Okay. This was basically for air. This was for the lens. Into 1 by R1 minus 1 by R2. What is R1 and what is R2? Pay attention carefully, my dear kids. If the light comes from here, yeah, this side will be obviously positive. This side will be negative. This is the first surface, so this is C1. This is the next surface, so this is C2. So radius 1 is basically this, and this is radius 2. So now think who is positive and negative. R1 is on the negative side, so minus 3. Okay, so therefore it is minus 3. R2 is on the positive side, so it is plus 5. That's it. That is the answer. Clear? Okay, how to substitute it? Somebody will be like, sir, I have an issue. What issue, bro? Sir, if I take that same diagram, but sir, how do I know what is R1, R2? Sir, you took light coming from the left side. Sir, I am a genius. You know what I did? I took the light coming from the right hand side. Oh my God, what to do now, sir? I'll get a wrong answer. We'll figure out. So this side light goes, so this side is positive, this side is negative. So this is the first surface, so this is C1, this is R1. This is the second surface, so this is R2. Do you understand how first surface and second surface is decided? Wherever the light hits first, that is first surface, so C1, R1. Okay, now let's do it again. 1 by f is refractive index of the lens is 2, of the medium outside is 1, so minus 1, 1 by r1 minus 1 by r2. R1, as you can see, is minus 5 because it is on the negative side. R2 is basically plus 3. Tell me, are both the answers going to be same or different? Are both the answers going to be same or different? Come on, answer it quickly in the chat box. It's very obvious now. So whether you take R1, R2 like this or R1, R2 like this, that means light coming from this side or this side, or you turn the lens like this or like this, doesn't matter. Focal length this side or this side is the same. A breaking news this is. Yes. So basically it is the same. Very, very interesting, guys. Wow. Sir, what if, what if I have a plane surface, sir, and this lens is there, then what do I do, sir? Or a curved surface like this, and then a plane surface over here. Plano-convex or a plano-concave. Okay, we'll do that also, not a big deal. Let's say this is some radius I'm taking, chumma 3. Let's say some radius I will take it, let's say 5 something. Let's say this is 1.5 refractive index. Let's say this refractive index is something 1.8. Okay, chumma I'm taking something. What do I do now? So 1 by f is equal to something minus 1 and 1 by something minus 1 by something. Here also 1 by f is equal to something by something minus 1 into 1 by r1 minus 1 by r2. We want to figure out what these numbers are. Alrighty. First, let's see how the light is coming. Sign convention, R1, R2, everything matters. light comes from here like this. So this side naturally is positive, this side is negative. Same thing over here, light is coming like this. So this side is positive, this side is negative. If you see, the curved surface is the first surface which hits the light. So this is the first center. Naturally, this is nothing but R1. The curved surface radius is R1. The next surface is the flat surface. For a flat surface, you think and tell me what's the radius of curvature? What's the radius of curvature? Come on, my dear kids. If you have a curved surface, it has some radius. You make it more flat, the radius will increase. You make it even more flat, the radius will further increase. You make it absolutely flat, the radius will become infinity. Isn't it? Yes or no? The radius will become infinity. Perfect. So the second radius, R2 is basically infinity. So for plano surfaces, one of the radius will be infinitely large. Got it? Same way over here, the first surface is itself flat. So here R1 will be infinity. The first surface is flat. The second surface where the light enters has a center here. So this is R2. I believe many kids do not know how to take R1, R2 and the sign convention. And I'm telling you, my lecture will help you understand this. This entire part, if you watch it carefully, you would have got it by now. How to choose R1, R2 and when it is infinity and when it is not. Clear? So the smaller the surface and curved it is, radius is small. As it grows big, radius will become big, and when it becomes flat, it has become so big that it has infinite radius. Okay, so let's start substituting all these things. Lens medium is 1.8, outside is air. Lens medium is 1.5, outside is air. R1 is obviously infinity. R2 is basically positive 3. Put positive 3. R1, oh, it's on the positive side. So 5. R2, it's on the negative side. Anyways, it is infinity. That's it. That's how you solve it. So this will become 1.8 minus 1, which is 0.8. What is 1 by infinity, guys? What is 1 by infinity? It is 0. So 0 minus 1 by 3. So if you want, this will be nothing but 0.8 with a negative sign by 3. But that is 1 by f. So f will be minus 3 by 0.8. If you want, you can simplify it. 0.8 is nothing but 4 by 5. So it will become minus 15 by 4 as the answer. Same thing over here, 1.5 minus 1 is 0.5. Then 1 by 5, I'll just keep it like this. Okay, 1 by infinity is 0. So 0.5 into 1 by 5, 5 cancels, it will be 0.1, which is 1 by 10, but that is 1 by f. So f will be 10. So that's how you solve the questions. Got it? Everybody with me on this? Clearo? Absolutely. Let me know quickly in the chat box. Yes, no, understood, sir. How to choose the sign convention R1, R2, and how to basically use the lens maker formula. If you had to find the power, like for example, in this particular scenario, if this is 10 centimeters, this is 10 centimeters, this will be nothing but 0.1 meter. So if you have to find the power, then the power will be 1 by f. F is 0.1. So it will be basically 10 diopters. In this case, if you want to find the power, remember this is again in centimeters. So you have to convert it into meters. So divide it by 100. So like this, my God, crazy. 4 into 100. You can do some simplification. I mean, big deal if you want. So 15 by 5 is 3. 100 by 5 is 20. So this is going to give you minus 3 by 80 meters. Perfect. So the power will be 1 by f. F is minus 80 by minus 3 by 80. So that will be negative 80 by 3. Negative 80 by 3 diopters. That is the answer. Cool? Yeah. Diopter is just a unit. Like what is the meaning of Newton? Okay. Or what is the meaning of Joule? Just a unit. Okay. So, yeah. Loved it, William. Okay, sorry, you are very, 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 very late. Ayo, you're actually very, very late, man. Almost nearing the end of the concepts. Okay. So now that we understand it, let's solve some more questions. JEE 2025, what are the questions asked? The radius of curvature of thin convex lens are 10 and 15. The focal length is this much. Oh, opposite question. What is refractive index? They have asked exactly opposite. So let's draw the lens. Okay, thin lens are 10 and 15. So let's say this is 10 and let's say this is 15. Let's say the light comes from here. So this side is positive, this side is negative. This is the first surface where the light hits. So that center will be C1. So this will be R1. This is second surface. So this will be C2 and this will be R2. Okay, now let's write down the formula. 1 by focal length. The focal length is itself 12. Refractive index is asked. 1 by R1. R1 is positive, so plus 10 minus 1 by R2. R2 is negative, so minus 15. Understood how to solve it? Now you can easily solve and get the answer. So this will be mu minus 1 and minus minus will be plus. LCM is 30. So this will be 3 times and this will be 2 times. Okay, so mu minus 1. 3 plus 2 is 5. 5 by 30 is 1 by 6. This is 1 by 12. 6 and 12 cancels. 1 by 2 is mu minus 1. So mu will be 1 plus 1 by 2, which is 3 by 2, which is 1.5. So 1.5 is option number 3. Absolutely correct. That's how we solve it. Yeah. No, William, there are more sessions. Prism is there, man. Prism is there. So we have to solve Prism also. Okay, great. Let's go to the next one. Coming up on your screen, a convex lens made of glass. Refractive index has a focal length. When it is immersed in water, what is the focal length? Now, interesting question. You have a lens. In air, it has this focal length. In water, what is the focal length? Crazy. So see guys, our regular formula of focal length 1 by f in case of air will be refractive index of the lens. Refractive index of air is 1 minus 1, 1 by some R1 and R2. I do not know what they are. When you dip it inside water, the only difference is lens's refractive index is same, but medium is refractive index of water. That's it. And you have 1 by R1 minus 1 by R2. Now just imagine somebody decides to divide this with this. Yes, you divide both of them. The moment you divide, what will happen? Think this is 1 upon something. So focal length of water or focal length in water will go up. Focal length in air will remain below. Okay. Mu L minus 1 will stay. Mu L by mu W minus 1 will stay. This and this will get cancelled out. How many of you could see that? Yes, this will just get cancelled out. It doesn't matter whether R1, R2 is given, not given. Isn't it? Crazy, right? So these got just cancelled out. Now it's just a matter of solving it perfectly. Okay, let's solve it. Okay. Focal length in water is exactly what I do not know. Focal length in air, I think it is given, which is 24, is equal to lens refractive index is 1.5. So minus 1 divided by lens by water. Lens is 1.5, water is 1.33 minus 1. Crazy. Okay. So this will become 1.5 minus 1 is 0.5. Okay. 1.5 is 3 by 2 and 1.33 is 4 by 3. So this minus 1, crazy things happening in the denominator over here. Wow, okay, 0.5 is, okay, we'll take care of it later on. So 0.5 and this whole thing, 9 by 8. So 9 by 8 minus 1. So that's what it will be, 9 by 8 minus 1. 0.5 is half. So 9 by 8 minus 1 is 1 by 8. So this will become 8 by 2, which is basically 4. So that is focal length in water divided by 24. So therefore, focal length inside water will be 24 multiplied by 4, isn't it? So this will be nothing but 96. So 96 is option number B. 96 is option number B. That's how you solve it. Got it, everyone? So these kind of questions are again common. Now, one thing I realize that lens, when the medium changes, the focal length will change. Like in water, it is different, in air, it is different, etc. But that was not the case of mirror. And that Laddu question came in JEE, that if you take a mirror and immerse it in water, what is the focal length? Many people thought, oh, focal length, refractive index will increase, this will happen, that will happen. And then they wrote increases, decreases, something and all. And then they came out of the exam hall and they thought, wait a minute, it was a mirror, it was not a lens. Oh my God. For a mirror, the focal length R is 2f. That's it. No question of mu. They had their head with shame and disgrace. So be careful. Look at the question. Only lenses focal length will depend on medium, not for mirrors. Second thing, it's a very interesting thing. Imagine it so happens the medium outside has more refractive index than the lens. Oh, what will happen, sir? See, usually what happens is this number here, mu minus 1, is positive. But if the outside medium is denser than the medium inside, then this terminology will become negative. So whatever focal length you get, if it was positive, it will be multiplied by negative number, means it will become negative. If it was negative, multiplied with another negative, it will become positive. Means the moment outside medium is denser, this term becomes negative, which flips the sign of the focal length. So whatever focal length which we have found, whether this problem, any problem, like you take this problem or this problem, if it was positive or negative, it will change the sign, which means what will happen, guys? Which means what will happen? If it was positive, it is becoming negative, means if it was converging, now it becomes diverging. If it was diverging, it becomes converging. So convex lens need not be always converging. A convex lens can be diverging if it is placed in a medium which is denser than the lens medium. Same way, a concave lens need not always be diverging with a negative power. It can be converging if the outside medium is denser than the lens medium. Is that absolutely clear? Just refresh BD William. I hope it will be clear. Just try it out. Is this concept clear? How lens focal length depends on the outside medium and can change the sign also. But for a mirror, it's absolutely dependent on the curvature only, nothing else. Please note down this point. Okay, by the way, based on this medium change, I have kept some homework questions. Just solve this. And also, yeah, this one. Yeah, this is the homework question. Correct. All right. Now, let's go to the next concept and the last concept, which is the lens maker formula. As simple as that. So if you have a lens, maybe the object is here, maybe the image is here, something and all I'm drawing. This is the object, this is the image, this is the object distance, this is the image distance, maybe the focal point is here, this is the focal length. Then the lens formula says, very, very interesting, 1 by V minus 1 by U is 1 by F. If you remember, for mirrors, what was the formula, guys? For mirrors, what was the formula? 1 by V plus 1 by U is equal to 1 by F. Here, that plus becomes minus. If it was minus, it will become plus. That's it. So that's the only difference in the formula. Nothing else. That's the only difference in the formula. Yeah. So for mirror, it was a plus sign. For Length, it is a minus sign. You know the image distance, you can find object distance. You know object and image, you can find focal length. Anything, vice versa. So even the magnification formulas are very, very identical. Let me tell you that. So if you have, oops, if you have, this is the object, maybe this is the image, this is the principal axis, this was our lens, maybe this is the height of the object, maybe this is the length of the object, this is the height of the image, this is the length of the image. So magnification, guys, magnification. Magnification, first is transverse magnification. This is called transverse, meaning it is perpendicular. This is transverse magnification, is height of the image upon height of the object. Similarly, you have longitudinal magnification, which is along the principal axis, that is length of the image upon length of the object. The formula is as follows. You just take V by U, no need of minus sign. Here you take V square by U square. That's it. This is V square by U square. Same looking formulas, just a change of sign, my dear students. Nothing else. That's the only difference. Yeah. What is longitudinal? Longitudinal, long, along the principal axis. So imagine I'm standing in front of the lens. Shreyas sir's image is formed. Maybe Shreyas sir is looking taller, but Shreyas sir might become fat or Shreyas sir might become thin. So along the principal axis, the length changes which occur, they are called longitudinal. Got it? Understood? Yes. Perfect. Perfect. Amazing. Clear. This formula also, by the way, is equal to one more formula. If you remember, yep, the object might be moving with some velocity, VO. The image might be moving with some velocity, which is, let's say, VI. So that is image velocity by object velocity. These are basically the ratio of speeds, the ratio of speeds of those objects and images. So that is an extension which is similar to the longitudinal form. Okay, so keep this in mind. So this is not just this, but also ratio of image velocity by object velocity. Let's solve some questions. Only then you will get confidence in all of them. Okay. Let's take. Let's say object is at a distance of minus 60 centimeters. Focal length is, let's say, 20 centimeters. Find the nature of the image, magnification, everything. Okay, let's try to do this. So first of all, U is given, F is given, V, image distance, everything we have to find. So let's start with the length formula. 1 by V minus 1 by U is 1 by F. Object distance, as you can see, is negative 60. F is basically positive 20. So this is positive, which is going to go on the other side as a negative number. Plus becomes negative over here. The LCM is obviously 60. 20 goes with 63 times. So 3 minus 1, which is 2 by 60. So therefore, 1 by V will be 1 by 30. Therefore, V will be 30 centimeters. Everyone fine? We got the image distance. Once I know image distance is plus 30, since it is positive, means it is on this side. So the image is going to be real in nature. If it was negative, that means I'll have to see through the lens and only then I can see that. So hence it is real in nature. Magnification, if you ask me, it is V by U. V is 30, U is minus 60, which is minus half. What does this minus tell you? It is inverted. It is inverted. And because it is half, it tells me it is smaller. It is basically smaller in size. Is that clear? Just 1 second. Okay. Next, let's solve one more question. Sir, could you make a video for problems and mirror? Yeah, that is the next lecture where we'll do combination of lenses and silvering of mirrors or silvering of lenses, all that, and some mixed questions also. That will be the next class. Okay. All right. Let's do one more question, guys. Coming up on your screen, we have a concave lens whose power is given to be 10 diopters. Sorry, minus 10 diopters, and it is also told that there is some kind of an object which is moving at 2 millimeters per second like this, and it is at a distance of 20 or let's say 30 centimeters from the lens. Question is, find the nature of the image and its velocity. Find the nature of the image and its velocity. Let's try this question out. Let's see what can we do. First come first, the rays from the object will come out like this. They are going this side. So this side is positive. This side is negative. Obvious. Next, 1 by V minus 1 by U is 1 by F. Image distance I do not know. Object distance I definitely know. It is at 30. But on the negative side, so I will put minus 30. Focal length, oh, that is not given. So I have to figure it out first. So power is given and power is 1 by F. So minus 10 is 1 by F. So F is minus 1 by 10th of a meter. But this is in meters. So I have to convert it into centimeters for everything else. So this is this. So it will be minus 10 centimeters. So focal length is minus 10 centimeters, which I'm going to put over here. Okay, now let's solve it and see what do we really get. So 1 by V is equal to, this minus becomes minus only. So minus 1 by 10, minus 1 by 30. So LCM, here is what I can do. Minus is common. LCM is 30. This will be what? 3 times. This will be 1 time. So this will be minus 4 by 30, which is minus 2 by 15. But that is 1 by V. Therefore, V will be minus 15 by 2, which means minus 7.5 centimeters. Minus sign indicates that the image is going to be virtual in nature. If it was positive, it will be real. Next, let's figure out the normal magnification, which will be V divided by U. V is minus 15 by 2. Object distance is minus 30. Okay, so minus minus cancels. 15 by 30 will become 1 by 2, and this 1 by 2 is there. So it will become 1 by 4. So it means the image is diminished. It is diminished because it is 1 by 4. It is smaller than 1. And because the answer is positive, that means it is going to be an erect image. If it was negative, inverted, positive means erect. So M is also done. So the nature of the image, everything we figured out. Last thing is the velocity. We all know image velocity by object velocity is v square by u square. Image velocity I do not know, object velocity is 2, okay. V by u whole square, v is minus 15 by 2 and u is basically minus 30, square this. So minus minus cancels, 15 by 30 is 1 by 2 and this is also 1 by 2 and have to square this, so which is 1 by 4 square, which is 1 by 16. So that is vi by 2. Therefore vi will be 2 by 16, which is 1 by 8 millimeters per second. So image velocity is 1 by 8th of a millimeter per second. That's the answer. Got it? So this kind of questions I'm pretty sure you can solve now. Clear, guys? Okay, so these are the kind of questions that you can get in lenses. Well, we'll solve one more question before ending the class because this is a good question. So where is it? Yeah, this one. Okay. Slanted object is placed on one side of a convex lens. The image formed will make what angle with the principal axis? Now, I'll tell you what, this kind of question, all you need to do is figure out the magnification. If you get the magnification on both sides, you will get the answer. I'll tell you how. See, this has some height, isn't it? 2 centimeters. That image height will also be different. We'll figure that out separately. And it has some length like this, the base of the triangle. That base length also, if you figure out, you can figure out how tilted that image is. So it's actually a question of magnification. Okay, try to visualize. The final image might be like this, where there might be some longitudinal magnification and there could be some lateral magnification. So based on that, we can solve the problem. Okay, so the first thing to do is obviously figure out where the image is formed. So 1 by v minus 1 by u is 1 by f. Therefore, 1 by v minus 1 by u is minus 30, is 1 by f, f is convex, so positive. So 1 by v is equal to 1 by 20 minus 1 by 30. LCM is 60. This will go 3 times, this will go 2 times. 3 minus 2 is 1. So 1 by 60 is 1 by v. So therefore, image distance is 60 centimeters. Now let's look about lateral or transverse magnification. So this magnification height wise is v by u, which is height of image by height of object. So v is 60, u is minus 30. Height of the image I do not know. Height of the object was 2 centimeters. So this height of the image will become 60 by 30 is 2, 2 2s are 4, so minus 4 centimeters. Keep that on the sidelines. Next, let's go horizontally, longitudinal wise. So longitudinal magnification is v by u whole square, which is length of image by length of object. Okay, so v is v is 60, u is minus 30. Okay, whole square is length of image by length of object. Length of object is horizontal, which is 1 centimeter. 60 by 30 is 2, so 2 square. So 2 square is length of image. So length of image is basically 4. Now this is 4, this is minus 4. What this means is that if you look at the principal axis, the height is negative, that means it is below. The height is negative, that means it is below. Lengthwise, it is 4 centimeters. So this is what it is, 4 centimeters. So this triangle has been inverted and finally the actual object will be like this. The actual, image will be like this. So this clearly tells that, boss, this is 45 degree and with the principal axis also you are making 45 degree. Hence the final answer will be 45 degrees. Yeah, it will be 45 degrees, but on the negative side, Why negative side? Because it is below the principal axis. If it was above, positive, below, negative. That's all. So what a beautiful question of ray optics which has come. Yeah. Yeah. -4 means it is below the principal axis. Positive means above. Remember sign convention, any height above is positive, any height below is negative. So don't think, so what is the meaning of negative height? It's just a sign convention. Height wise it is 4, but it is below. That's all. Okay. Beautiful question. So I have given you already one homework. Make sure you solve it on time. All right. It's based on that medium change and all of that, which was asked previously. And we have almost done 60, 70%, 80% almost of the chapter. The only few things which are remaining are prisms, what we'll do, and then the combination of lenses, right? So take care, guys. Have a great time. Bye bye. Hasta la vista.